G'day. So, we're going to talk about plate boundaries today, and essentially that is where two crustal plates meet. Okay, pretty straightforward. So, transforming and scraping, we'll start with some definitions of the different types of boundary meetings, and then we'll go into detail about how they are and what they work. So we have transform, so you can write that down if you want. Transform scraping boundaries. A transform boundary is one where the two plates are rubbing against each other. They don't collide this way, they go against. And they're conservative, and what that means is that no new plate so plates aren't created or destroyed, they stay the same, the same amount. You have divergent or spreading plates, and these are plates which go apart from each other. These are constructive plates, and that means that as you pull them apart, new stuff comes up underneath and makes crustal plates. And then we've got convergent or collision plates. This is where they collide, and these tend to be destructive plates. In other words, one of the two crusts is destroyed as it creates a subduction zone and goes down beneath into the mantle. So yeah, that's our three types of plates that we're going to talk about so much. These ones create faults, by the way, which become a big deal later on, and we'll get to that now. If we bring this over, we'll start with the most complex of the three, and it's collision boundaries. So this should say oceanic continental. Alright, so with an oceanic continental collision, so you've got the thick, dense oceanic crust and the light, wide continental plate, and the oceanic crust and the continental plate, crust collide. The denser one, because it is denser, it's heavier, so it sinks beneath, and it melts back into the crust and is recycled that way. And we see that here, so it goes along, it melts. These points here, there's lots of friction, and this can cause earthquakes, so it might get stuck and then free up, and that energy is released as an earthquake. It creates a trench, an oceanic trench just here, and you see that, so this one goes down, melts, and it can cause, as it melts, it can, so that's due to friction, can come back up and be released as a volcano. Not always, but it does, and the Andes, that's what's going on there. So possibly a volcano, definitely a trench, and earthquakes here. What happens to the continental plate is quite interesting. So this one sinks down, but the continental plate is still being pushed forward, so that means it folds, it buckles like at the front of a car. It's in a crash, so it's, was like this, and then it crunches up and pushes up above here, and we get a mountain. So that's that is what we call a folded mountain. Now, oceanics, that's two oceanic plates bumping into each other. Because they're roughly the same density, the fastest moving sinks. So of these two here, obviously this plate was going faster because it sank down. We get another trench, a deep trench. The upper plate gets thicker. I'm going to ignore that part of the diagram. The upper plate gets thicker, and where it melts into the crust here, into the mantle here, it pushes up, and you get an island chain. These are all volcanic islands, and as the molten rock from the mantle comes up, it hits the water and it freezes, essentially, so it solidifies, and we get islands and volcanoes. Continental. So you get a crumpled fault. The two, again, similar density, and they crash into each other, and big mountain. But that's where your really big mountains come from, like Everest and the Himalayas, etc. So the base melts here and forms what we call the mountain root, and that's very strong, and it won't erode. The rest of it will all erode, but this will sort of always kind of be there. And yeah, so we get this really large mountains. So those are the collision boundaries. Now, if we move along, you can see other two, we've got divergent spreading boundaries, so that's where the two plates shift apart from each other. They're pretty simple. Magma comes up, fills the gap, and creates a new crust. Now, as they pull apart, new magma is trying to push up. That will cause the inner younger layers to crush against each other and crack, and that leaves a gap that new magma can pour up, and the process just starts again. Usually beneath the ocean, but not always. There's one in the Middle East, and there's one in Africa, and they create rift valleys. Now, it's transform or scraping boundaries. Okay, so you don't get mountains, you don't get volcanoes, you do get the strongest earthquakes from transform and scraping boundaries. Most of these are under the water, but there are some on land. For example, the San Andreas Fault is the largest. It goes for 1,300 kilometers down through California in the US, and that's why we always see Los Angeles having such strong earthquakes in the movies. These create faults, so cracks in the crust, and that's where we're at for the types of plate boundaries. So get down some notes, and yeah, I'll see you in class.